Once you've learned the first and second derivative tests, the next thing they're usually likely to ask you to do is to use those two tests to actually sketch out a graph of a function. So without your calculator, they want you to not give them the exact graph, but give them a graph that pretty much looks like what this graph is. So to do that, we need to start off, they kind of stole our thunder by telling us we need to use our first and second derivatives. So step one of the process is we're going to need to find our first and second derivative. So we're going to find f prime of x. So that'll be what we do here. We're going to kind of run these together. So finding the derivative of that given equation, we're just going to be doing our power rule here. It's just a bunch of stuff being added and subtracted. So we bring the power down. We get 5 times 3 gets us 15. X, subtract 1 from the power gets us x to the fourth, minus, bring the 3 down, 3 times negative 20 gets us negative 60, x, subtracting 1 from the power gets us x squared. Then from there, again, we just kind of run these at the same time. My brain says I'm already taking derivatives, so I might as well do the same thing on the second derivative test. So I'm going to go ahead and find the second derivative now. So then finding the derivative of that derivative we just took over here. So again, just applying the power rule because it's stuff just being added and subtracted. We bring the 4 down. 4 times 15 gets us 60. X, subtract 1 from the power gets us x to the third. Bring that 2 down. 2 times negative 60 gets us negative 120. Subtract 1 from the power gets us x to the first. So step one of the process for both first and second derivative are complete. Then step 2 of the process on this side is we need to find critical values. So critical values occur in 2 places. They occur when our first derivative equals 0 or when our first derivative is undefined. You really only want to worry about the undefined situation if you see yourself having a fraction with x's on the bottom, because then you'd have to worry about where you would get division by 0, because that would make the problem undefined there. And then the other place is if you have endpoints of your interval. We don't have either one of those situations going on, so we're just looking at the more straightforward version of finding a critical value, which is just setting this thing equal to 0 and solving it out. When we do that, as soon as you see you've got a power of 2 or greater on your problem, 99 times out of 100, you're going to go ahead and need to factor this to solve it. So factoring this, I can pull a 15 out of both pieces. I can also pull an x squared out of both pieces. So pulling the 15 out of there brings that. Taking 2 x's out leaves me with an x squared, minus pulling 15 out of 60 gets me a 4, and then I pulled all of that x squared to the front. So we end up with 15x squared times x squared minus 4. The reason we do that is now that these two things are being multiplied, we can now separate them out into 2 smaller problems. So we want to know whenever 15x squared equals 0, and we want to know whenever x squared minus 4 equals 0. So we'll solve both of those little problems. Divide by 15, we end up with x squared equals 0, and then square root both sides of that, and we get x equals 0. So that is one of our critical values right there. Playing the same game on this other one, we go ahead and add the 4, we get x squared equals 4, then we square root that, and we end up with x equals plus or minus 2. Right? Whenever you apply the square root function, you get the plus or minus. So essentially out of here, we get 2 different critical values. We get x equals negative 2, and we get x equals positive 2 for our critical values. So like I said, when my head is working in a certain space, I like to keep it there. And so now what we're going to do is we're going to go over to this other side, and we're going to do step 2 on the second derivative test, which is going to be to find those possible inflection points. Well, guess what? Inflection points happen when the second derivative equals 0 or the second derivative is undefined. In this situation, we don't have any fractions and we don't have any endpoints. So again, we don't have to worry about the undefined scenario. What we're going to worry about is just the one where this equals 0. So we take our second derivative and we set that equal to 0 and solve that equation out. And again, like we saw in the last one, we've got a power bigger than 2, so it's telling me that I probably want to factor this thing. So factoring this out, I've got a 60 in both pieces that I can pull out, and I have an x in both pieces that I can pull out. So I pull a 60x out, that leaves me with x squared in the front, and then a minus 2 in the back. Now, just like on the other side when we did this, the reason we do this is now we can take each of these little individuals and set them equal to 0 and solve those little math problems. And that's going to give us our possible inflection points. So then coming through there, divide by 60, divide by 60, we end up with x equals 0. That's a possible inflection point. We add 2 and add 2. That gets us x squared equals 2. And then again, square root it, and when you square root it, you end up with the plus minus version of that. So we get plus or minus the square root of 2. So really out of here, we get x equals negative root 2 and x equals positive root 2. Those are also possible inflection points. Now on to step 3 for both of these processes. This is where we do that number line game. So step 3 is where you actually do the first derivative test. The first D test, as I call it. So then what you do is you're going to draw out your number line. You're going to mark your critical values. So we're going to start over here at negative 2. That's a critical value. We've got 0. That's a critical value. I guess I made my number line huge and I didn't need to. And then we've got x equals 2. That's going to be my critical value. And then from there, I need to come through and I need to choose test values in each of those regions. So I'm going to choose something to the left. I'm going to go with negative 3. Something in the middle here, I'm going to go with negative 1. Something in the middle there, I'm going to go with 1. And then something outside here, I'm going to go with positive 3. So this is a first derivative test. So we are testing everything in our first derivative, what we got out from step 1 here. So we are going to do f prime of negative 3 equals, f prime of negative 1 equals, f prime of 1 equals, and then f prime of 3 equals. And as we do this, we don't really care about the number, right? We really just care about the positives and the negatives that come out of there. So then plugging in negative 3 to our first derivative up here, back from step 1, plugging in negative 3, we get out a positive 675. So I come up to my number line, I put a plus sign, and I draw an arrow up. That tells me that it's increasing in that section. I plug in negative 1 to my derivative, and I get out negative 45. I got a negative, so I put a negative, and I draw myself a little arrow right there. Plugging in 1 to our derivative, we again get out negative 45, put my negative sign, draw my arrow. And then on the last one, I plug in 3 and I get out a positive 675. And so I get a positive, and then that's going up. So there's my first derivative test. And now what we're going to do is we're going to do the same thing with our second derivative. So step 3 on this side is do a second derivative test. A second D test, a number line game, this time using our second derivative. So same type of process. We're going to draw out our number line. We are going to mark those possible inflection points. So we start on the left here, we get negative root 2. We start in the middle here, we get 0. And then the one outside here is going to be the square root of 2. And now here, again, we're going to do just like we did on the last one, and we're going to choose test values from each of our regions. So I'm going to choose a number out to the left here. I'm going to go with negative 3. If you don't know what the square root of 2 is, pop it into your calculator. It's 1.414, but you'll need to know that to choose points in between. I'm going to choose something in the middle here, negative 1, something outside here, 1, and then something outside there, 3. So this is now a second derivative test. So we are going to test all of these values in our second derivative. So we're going to do f double prime of negative 3. We're going to do f double prime of negative 1. We're going to do f double prime of 1. And we are going to do f double prime of 3. And again, we just care about positives and negatives. So coming through this thing now, plugging in these values, I plug in negative 3 to my second derivative, and plugging in negative 3 is going to get me out negative 1260. Don't care about the number, again, just care positive or negative. Negative in a second derivative game tells me where the graph is concave down like a frown. Then I'm going to go ahead and plug in negative 1. Negative 1 gets me out of there positive 60. So I put a little plus sign, and that tells me that this thing is going to be concave up like a cup. Plugging in 1, I'm back to negative 60 here. So negative tells me concave down like a frown. And then I plug in 3, and I get out of there a positive 1260. So then I get positive and concave up like a cup. So here at this point in our process, what we've essentially done right now is we have done a first and second derivative test. And now from that data, we want to be able to sketch ourselves a graph. And so to do that, that's when I do what I call the combine number line. So we're going to create a number line here that grabs all of our data from our first and second derivative test, and we're going to use that information to tell us what the shape of our actual graph should look like. So you draw yourself out your number line, and you mark all of these critical values and all of these inflection points that you got. So we've got a critical value at negative 2. Then we've got an inflection point. You make sure you put them in order. It's going to be negative square root of 2. Or that's an inflection point, excuse me, not a critical value. Then from there, we would go past that and we end up with 0, which is both a critical value and a possible inflection point. Then after that, we get the value of positive square root of 2. And then from there, after that, we get our last critical value, which is happening at 2. And so what I do is I go ahead and I draw myself these little dotted lines for these different regions right here. So we're going to see what the behavior of our graph looks like for first and second derivatives. So we start off, the first one is f prime of x on this line. So we grab all of our first derivative data, reading it off of our number line over here. To the left of our critical value, we are in the positive space. So we bring this positive down here. Then I say in between negative 2 and negative square root of 2, well, that is when I am in this negative section because my critical value goes from negative 2 to 0. So in that section right there, the first derivative is negative. Going to the next section, that's the same little region. My first derivative is still negative right there. Then after 0, between 0 and the square root of 2, that's going to be this region right here. That's going to be also negative. Between the square root of 2 and 2, we're still in that region right here, so we're still in our negative. And then after 2, we are back out to a positive section. So we put our positive right there. Now we come and put our second derivative data on the same chart. So we're going to be reading off our second derivative chart. So to the left of negative 2, that's going to be this space right here. This is a negative second derivative. And between negative 2 and the negative square root of 2, we're still in that space, so that's still a negative second derivative. Now between negative root 2 and 0, we're in this positive space here, so that's going to be positive. And then between 0 and root 2, we are back into a negative space right there. And then between root 2 and 2, that's going to be when we're out here. And so that's going to be positive on this section and then positive again on that section. Now that we have both of those things labeled on our combined number line, we can now come back and see what the shape of our original graph is going to look like. So as we read these things, remember that each part of a concavity shape has 2 halves to it. So when we're doing concave up like a cup, you've got this side of a concave up and you've got that side of the concave up. So then also on a concave down, you got 2 sides. You've got this left side and this right side. So this would be the decreasing side. That's first derivative information. And then this would be the increasing side because it's going up. And so on this other one, then this would be the increasing side. And then this other half would be the decreasing side. So as you read this, you read through and you say to yourself, I have the increasing side of a concave down shape. So the increasing side of a concave down shape looks like this. You then go to the next piece and you say, I have the decreasing side of a concave down shape. So the decreasing side of a concave down shape is going to be that side. Then I move to the next one and I have the decreasing side of a concave up graph. So the decreasing side of a concave up graph would be this half. Then on the next one I have the decreasing side, and now I'm back to a concave down. So decreasing side of a concave down shape looks like this. Working our way through this, we have the decreasing side of a concave up shape. So the decreasing side of concave up is going to be this side here. And now we have the increasing side of a concave up shape. So our graph is going to look like that. So that's what the shape of this graph is going to look like. And now where these things are going to be connected at, where we connect those shapes, that's going to be at these critical values and these inflection points here. So the last move after that, before we just start putting this thing together, is we need to find the points. We need to know what the y values are that go with all of those x values we just created. So we need to know f of -2. That's a critical value. We need to know f of -√2. That's one of our inflection points. We need to know f of 0. We need to know f of √2. And then we need to know what f of 2 equals. We need to know all of those y values. Those are points off of the original function. So we are plugging all of those values back into this original equation to find the y values that go with them. So when we plug in -2 back into that original equation, we are going to get out 64. Plugging in +2 into that, we get out -64. Plugging in 0 to that, we get out 0. Plugging in -√2, we get out 28√2, which is an ugly number. And then when we plug in positive square root of 2, we're going to get out -28√2. To go ahead and sketch this thing, I come through now and I start by marking all of those points, because you know where those are. Those dots have to be where those things are located. There's no way of getting around that. You have to put a point there. So then what I do is I come back and I say, okay, at -2, I need a point at 64. So I'm going to put my dot right there. Then just to the side of that, at -√2, I need 28 √2. Again, you can put that type of stuff into your calculator and kind of get yourself an estimate for where it's located at. Then the next point that I run into is happening at 0, 0, 0. Then I get the positive square root of 2, which is going to be happening down here at that -28√2. And then I get my last point, which is happening at -2, or excuse me, which is happening at +2. And that's going to get me out at -64. So I'm going to have that point there. So I have to go through those points, and I have to have the shape that I listed up above. So coming into that first critical value, my graph needs to look like this. So I come in like that. Then in between there and my inflection point, that next dot on the graph, my graph needs to have this shape. So I have it have that shape. Then I connect that up with the green piece right here. And so then that connects down to that point there. And then we go ahead and keep moving through. I now need to connect that shape at that point. So I connect that shape down to there. Then we connect our next section. This piece right here does something like that. And then we finish it out. The last portion is going to go up like that. And so from there, you have your sketch. So the process for sketching a graph is Find the first derivative, run a first derivative test. Find the second derivative, run the second derivative test. The key to understanding all this information is really, to me, this combined number line. You put all the data together and then you're able to read the shape of your graph off of that combined number line. Remembering that there are two sides of every concave up shape. So it's always one of those four shapes. And then once you know what the shapes are, you just need to, it's like a connect the dots game. You got to find the dots, put your dots on the graph, and then connect all of them with the shapes you said from your combined number line. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.